equation. Next slide. So this is the equilibrium equation for this part, and next we can see for other part also. So the basic of trusses is done, and we will see about its analysis on SAP by just covering about some basic of beam. So beam is the structure which is also strong and stable, and which resist the lateral load, and it is also used in bridges and building. Next. So this is just the example of loaded beam. So this load is, this is the next. So analysis in, see that the, if we can just simply apply the equilibrium equation. So we will see the simple steps. So for this example, we can, this is the simple example of beam, and this is the free body diagram for that. So first step to draw the free body diagram, and the second is to determine the reaction force and reaction moment at the beam support. So these are equilibrium equation itself. So we can take a section and we can take a section and say that this is the shear force diagram, and this is the bending, sorry, shear force and bending moment, and the direction will be in, we can take the general direction. These are just, and the direction on the other section will be just opposite to it. So after that we can solve the shear force and bending moment diagram also. And this is called the sagging, and we will see in the next slide that how the moment is applied on them. So the moment direction is just, the moment is in this direction, so it will be going in upper direction, and the tension will be in the top fiber, and the compression will be in the, and in this the compression, there will be compression in the top fiber. So this was the basic for truss and beam, and somehow the basic of truss and beams analysis. So we will see about the shapes intro and tutorial about it, and so you can start.
So now we will be solving one of the problems similar to that we have seen in the PPT. So for that, first we will go to File and click on New Model. And uh, for any structure, we need to define two basic things. One is the dimension of the structure, and the second one is the material we use for it. So we'll be defining that first. So the structure we saw in PPT was quite simple. So it is easy to calculate forces, but think of calculation in a bit complex structure. SAP makes analysis of such structures easier. So um, So this tab appears when we click on new model. So from here we can choose the system of units we want. I'm going for this one, and we can select from the following templates according to the structure we have to make. So our structure is a bit easy, simple. So we are going for grid only. Um, so this tab appears, and from here uh, uh, we can uh, choose our grid data. So from here we can enter the grid lines and grid spacing. So let's say I want 5 grid lines in X direction, 1 in Y, and 2 in Z. And let's say the spacing between the grids I want is 3 for each. So I enter 3 in all of them, and uh, then just press OK. So we get a grid system, and from here we can select the plane which we want to view. So I want to view XZ plane, so I go there. We can also view YZ plane from here. So um, uh, and so our grid data is now defined. So we can also edit this if we want. So we need to right click and go to edit grid data. So now we need to go to modify and modify or show system, and uh, we can see our system. So we have a grid data in X direction on 0, on ordinates of 0, 3, 6. So suppose we want a grid uh, after 3 at 4. So we can just enter the grid data which we don't want, and press the one which enter the one which we want, and if we enter, so we'll get a grade at 3, 4, 9, and 12. But let it be 6 here. And we can also add grid data. So let's say I'm adding one grid data in Y. Okay. So I'm adding one grid in Y direction. So I just need to go and press add. So you can see we have one grid data at 0, and the other one is also on 0. So let's change it to 3. So we enter it. So, and if you're satisfied with the grid data, you can press OK. So you can see we have now it's a 3D structure because we have two grid data in Y direction. And you can check the coordinates of the if we go here, we can check the coordinates of this point when we look at this point here. So like this is 000, this is 300, and this is 303. So we can uh, so we can check we are at correct points or not by uh, seeing that coordinates. So now dimensions are defined. We need to define material of the structure now. So for that, we go to define, we go to material, and here two materials are defined already, but suppose we want to define a new material. So we go on add new material, and we can choose the region from here. Uh, uh, so wherever we can choose the reason, we can choose the material type from here, and standards. Let's say and this is what I want to go with. So I press OK, and now I want to modify its property. So I can go to modify or show material. So when I press that, I can see the properties of the material which I just added. So we can change its name. Let's say let's name it truss. Um, the structure in PPT didn't had its own weight. The forces we calculated only for the dead loads, not for its own weight. So um, we'll put 0 over here, weight per unit volume, because we don't want its weight. So, and we can also change other properties, but I'm okay with it. So let's press OK. And again, okay. So now we have defined material. So we need to define its section property. So we go to section, define section property, and then frame sections. So we add new property to it. So we can choose any of the following section properties according to the structure of which we want to make. Let's say I choose tube. So now here are from here I can change the depth, width, and thickness of this tube which I have. I want my tube of the material which I have defined. So I go for truss, and then let's change its name to truss as well. So now we can press OK. So now we have our own section. So we press OK, and now we are ready to draw the structure. So for that, here there is an option called draw frame or cable. So we click that, and we can see the section name. It is just it is the same which we defined. So okay, we are now ready to draw. So you can enter you can enter and start drawing, and stop at every joint. And whenever you want to stop drawing, you need to double click. So uh, let's make it. So this is the structure which was in the PPT. So let's go to select mode. So let's click here, and now um, so So the PPT had had this point pinned. So we'll assign a pin over here. So for that, we select this point, and we go to assign, and we go to join and restraint, and we pin it. So now it's pinned, and there was a roller at this point. So we'll assign a roller to this. So we select this again, and we go to assign joints, restraint, and we can choose roller from here, and we can press OK. So we now have a roller over here. We also had one dead load over here. So we select this point, and we again go to assign, and this time we go to joint loads and forces, because we want to define a force over there. So we had the force of 20 kilonewton in negative z direction. So I'm putting minus 20 over here, and uh, I'll press OK. So now you can see we have a dead load of minus 20 kilonewton over here. So one more thing is that trusses are pinned, but in SAP these joints are rigid. So we need to release them against rotation. So for that we need, so what we do is we select the whole structure. For that we click and drag the whole structure in this box like this, and then we go to assign, we go to frame, and then we go to release partial fixity. So we don't want momentum. So what we do is we click on these boxes, and we ensure that these momentums are 0. So now we press OK, and now you can see that these green line signifies that these points are now pinned. So um, uh, now they have they are released against rotation. So um, if you don't if you don't want to see these assignments, you can also go to assign and clear display of assigns to get a simple view. So now the structure which we had in PPT is completed. So we can analyze this. So for that, we can go to analyze and run analysis. So we only want our analysis to run for the dead load we have defined, that is minus 20 kilonewton, and not the model. So we select the model, and you can see the action under model is now run, but we don't want to run that. So we click this run or do not run case. So now you can see the action under it is do not run. So now if we run the analysis, it will only run for dead load. So okay, let's run it. So to run, we have to save it. So let's save it with, so now the analysis is running, and this is the deformed structure of the structure we had made. So if we want to see the forces on it, we can go to a display and show forces or stresses. And if we want forces and stresses of joints, we can uh, click on this one, and um, let's click OK. So you can see that we got our forces on joints. Similarly, if we want to see the forces on different sections, we can again go to display and show forces. And this time we'll select frames, cables, and tendons. So um, uh, okay, let's uh, press OK. So you can see that we got the forces of all the sections, and so easily, and it would have been so hectic if we had done it on pen and paper. So, and if you further want to edit this structure, you can do so by unlocking this. So uh, so you can click on this icon, and uh, you can unlock this, and now you can further edit this. Like now suppose if you want to replicate a similar structure many a times, so you don't need to repeatedly draw it, but you simply what you can do is you can select the whole structure and then go to edit and replicate. So from here you can replicate it as many times as you want by changing the number over here. So I want to replicate it once, so I'll keep it one, and I want to replicate in y direction at three units, let's say. So let's press OK, and now you can see here this got replicated. So what further we can do is we can further define some materials. At first, we defined a material which was steel. Let's define a material which is concrete this time. So okay, we select material type to be concrete, and then we press OK. So now we can go and modify this material from here. So you can change the name of it, let's say base, and you can change any property from these places. These properties, you can change its value. I don't want to change anything, so let's press OK. So now let's press OK. Now we have defined the material. Now we need to define the section for that material. So we go to section properties and area sections. So we add new area, uh, uh, add new section. So let's name it base, and we need to ensure that the material name is same as we want it, as we have defined. We can change the thickness from here, and okay, let's press OK. So now let's say we want to add more. Uh, let's go to XY plane, and let's add some more elements to this. So let's add this. We can go one grid up or down by using these two. Let's say we want to go at this point, we are at the top of this 3D box. So let's say we want to go to the bottom, so we can just move down. So mm, we are at the bottom of this 3D box now. So let's add some more elements to it. Okay, so uh, let's now we can select draw poly area. So now you can see it is the same section which we defined for our concrete. So now we can start drawing. So stop at every corner of the uh, shape which you want, and double click at the end, and you can go to display, set display option, and if we go to general options and fill objects and apply to all window, we can see our slab now. So um, uh, what we can do is we can further uh, draw the areas, or we can select this one and replicate it further. So let's replicate it, and let's so I want to replicate this 3 times, and I want to replicate this in X direction at 3 units. So uh, so you can see now the whole bottom is covered with slab, and uh, if we want, we can go up a grid, and we can draw the same to the same again, or we can also replicate it at top as well. So when we look at it, this is a basic structure of a bridge. So we can run its analysis as well. So let's run it once. So model is action under model is do not run. So okay, let's run it. And okay, we can go and see we can go to display and show deformed shape to see the deformed shape of our structure. So this is how this bridge would turn out. Um, of course, this is a basic structure of bridge, but it is not the replication of an actual bridge, because an actual bridge would have different loads and it will also have its self weight, which we have considered to be 0 in this case. So tomorrow we'll be making a two-storied building, which on which we'll be putting lots of load, different types of loads. So um, you'll know about it more tomorrow. So for today, we are done. If you have any doubt, you can ask, or you can also join our Discord if you don't have now and want to ask later.
So, okay, so we are ending our workshop here only. So for tomorrow, we'll be building a two-story building. So the timing will be same. So see you soon, guys. See you tomorrow at the same time. Okay, so if you want to discuss anything, you can stay here. Otherwise, you can leave the meeting. Okay, so I think we can end this meeting here. If no one interested in asking, okay. So bye, guys.